Alright, we need to talk about solubility rules and how they apply to reactions. So hopefully you watched the previous animation on how solutions are formed. We're going to take a look at how to tell if something is soluble or insoluble. So, for example, let's start off with something we know to be soluble, like sodium chloride. When we call sodium chloride aqueous, that means we take table salt, sodium chloride, we dissolve it in water. It disappears from sight because the sodium chloride ions actually break apart into Na plus and Cl minus. So inside a glass of salt water, you don't actually have NaCl's floating around in there. What you have is billions upon trillions upon millions of Na pluses and Cl minuses. So sodium chloride aqueous isn't actually sodium chloride, it's sodium and chloride existing separately. And this goes for any soluble compound. So if you have something like MgCl2, also soluble, magnesium chloride, if that is aqueous, you actually have Mg2 plus and Cl minuses, and you'd have two of those because of the Cl2. And so everything breaks apart, it ionizes. That's what aqueous means. However, not all ionic compounds are soluble. So something like PbI2, lead iodide, is insoluble. That means if you put it in water, it's going to form a solid. It's not going to be aqueous, which means in water it is literally PbI2. As a result of its lack of ionization, its inability to break apart into ions means that it does not disappear from sight. It merely falls to the bottom, but it's going to stay a whole compound. It's insoluble. It precipitates down. What this means is the bond between lead and iodide is so strong, their love is so powerful, that nothing can break them apart. That's pretty impressive. Alright, here are the solubility rules that you got in class. And so this is kind of a long sheet with a lot of information on it, but we'll get some practice kind of navigating it. And so what it tells us is whether something is soluble or insoluble. So there's a list of rules, there's a list of exceptions to the rules. So we need to just make sure that we read through this carefully and do practice using it. Okay, I do want to point out the two most important rules on this sheet, and that is rule number 1 and rule number 2. Mostly rule number 2, though. So rule number 2 says that all alkali metal compounds, so that's any metal compound from group number 1, are always soluble. That means anytime you see an alkali metal in an ionic compound, it is instantaneously soluble. There is no exceptions to that. So that means lithium, sodium, potassium, rubidium, and cesium always form soluble compounds. You will never make a precipitate from those guys. Same thing goes for ammonium, which is NH4+. All of those compounds are always soluble. That is the number 1 rule. The first rule, though, on this list is the one that says that all nitrates, all chlorates, and all perchlorates and acetates are always soluble. Most importantly from that would be the nitrates part. So all nitrates, anything involving NO3, is instantaneously soluble. AQ goes next to it. Other than those common ones, you're going to have to look at this sheet and kind of read through to figure out whether or not something is soluble. Okay, so here is 4 examples of ionic compounds. We're going to decide whether or not these are soluble or insoluble. So in order to do this, you got to look at the 2 players in there. So this is made up of barium and hydroxides. We need to read through the rules and see if we can find anything about either barium or hydroxide. So as we scan through it, when we come down here to the insoluble, rule number 3, it says that all hydroxides are insoluble. That means they form solids. But, keep reading, except those of group 1, so one of the alkali metals, and barium hydroxide. That means barium hydroxide is an exception to this rule. So if all hydroxides are insoluble, barium's an exception, that means it is soluble. So that means placed in water, this is going to form an aqueous compound. Next one is silver chloride, so we're looking for silver or chloride. We scan through the rules, and right here, rule number 3, all chlorides except silver chloride are soluble. So that's one of the exceptions for the chloride rule, which means that it is not soluble, and so it's going to be a solid. Next is potassium carbonate, which has potassium and carbonate. So we can look through the rules, but hey, I want to remind you, rule number 2, all alkali metals are always soluble. That right there is an alkali metal, so we didn't even need to read through the rest of the rules. If there's an alkali metal, it is instantaneously soluble, and so it gets itself an AQ. Okay, and the last one is iron sulfide. So just scanning through the rules again right here. All sulfides are insoluble except for group 1 and group 2 metals. Iron is a transition metal, so it's neither group 1 or group 2, which means this one follows the rules. It is a solid, insoluble. Okay, you're going to get the hang of these. You're going to pick up what's on this list, but just as you're getting used to it, make sure you read through the rules very, very carefully, look for exceptions, try and find the players. So kicking it up a notch, here's an example of the type of problem that we're going to see with this and why it matters for this unit. So if we have sodium chloride reacting with silver nitrate, we should by now recognize this as a double replacement reaction. We have a couple here and we have a couple there. They're going to partner swap. And so we're going to put the metal here with a nonmetal there and the metal here with a nonmetal there. And so when we put our charges to balance out, it actually comes out nice and even, and we would get Na, NO3, and AgCl. So now over on the reactant side, we see that both of these are aqueous. They're both solutions, so we pour them together in order to form these two. So we need to predict then, is this going to be aqueous, and is that going to be aqueous, or are they going to be solids? Will it precipitate form? Voila, the solubility rules. So we can look at our reactants and we can verify right here we've got a group 1 metal. Group 1 metals are always soluble. That's why sodium chloride is aqueous. And then silver nitrate. Nitrates are also always soluble. That's why there's an AQ there. So now we can apply that over here on this side. So we have both rule number 2, group 1 metal, always soluble. We also have nitrate, rule number 1. So both of those say that this guy should be soluble, which means, what do you know, silver nitrate is going to be soluble. Okay, now let's look at silver chloride. So silver and chloride, if we look through the rules, yeah, right there, all chloride's soluble except for silver chloride, which means that is insoluble. It's going to make a solid. If it makes a solid, that means it is a precipitate. So when we mix these two solutions together right here, what we're going to create is a precipitate, so a solid that falls to the bottom. So that's it. Solubility rules let us tell whether or not an ionic compound will dissolve in water. It also lets us look at a double replacement reaction and decide whether or not a precipitate will form, whether we're going to have two aqueous compounds, therefore no precipitate, or whether we'll have something that's insoluble and a precipitate.